How do you dismantle a high-tech nomadic city worth billions of dollars, pack it into bespoke crates, transport it across oceans and continents, navigate a labyrinth of international customs, and rebuild it flawlessly in a different hemisphere, all in less than 89 hours? This is Critical Path, where we explore stories and innovations about our global supply chain that connect our world to your everyday life. Picture the scene. The champagne has barely dried on the podium. The confetti is still settling on the searing asphalt. For the hundreds of millions of viewers watching the television broadcast around the globe, the race has concluded in a crescendo of engineered perfection, and the spectacle is ostensibly over. The drivers have hoisted their ridiculously heavy trophies, the national anthems have been played, and you are probably reaching for the television remote to turn off the broadcast and get on with your Sunday. But down in the pit lane, hidden behind the VIP hospitality suites and the blinding flash of media cameras, the true endurance race is only just beginning. The task at hand is so monumental, it borders on the completely absurd. To fully comprehend the logistics of a top-tier open-wheel racing team traveling to flyaway races outside of Europe, you have to suspend all of your traditional notions of transportation and freight. We are not just tossing some duffel bags into the trunk of a sedan. Over the course of a 24-race season, the entire grid of racing teams transports roughly 1,500 tons of equipment. That equipment travels a collective 75,000 miles, a distance equivalent to circumnavigating the Earth 3 times. If you zoom in on a single team, the numbers become even more surreal, reading less like a sports schedule and more like the mobilization of a small, hyper-caffeinated military. The sport's official logistics partner estimates that each team ships the equivalent weight of 8 adult elephants per race. That aggregates to 50 tons of cargo transported annually, at a cost of upwards of $8 million per team. To move the entire paddock from one race to the next across Europe, organizers must coordinate a fleet of up to 300 articulated trucks. If you place these massive trucks end to end, they would form a continuous, unbroken convoy stretching over 5 kilometers long. For the global flyaway races, this terrestrial armada is traded for an airborne one, requiring the chartering of 6 to 7 Boeing 747 cargo planes per event. Over a single season, teams will ship 660 tons of air freight and 500 tons of sea freight, demanding the tireless coordination of over 100 dedicated logistics professionals on the ground. This is not merely the movement of sports equipment. It is the synchronized, global relocation of an aerospace engineering firm, a 5-star culinary operation, a broadcast media empire, and a high-performance athletic facility. A single lost crate, a delayed flight, or a misunderstood customs form does not just cause a minor inconvenience. It can effectively end a team's championship campaign before the engines even have a chance to fire up. The logistical operation actually kicks off while the cars are still navigating the track at speeds exceeding 200 miles per hour. As the race enters its final laps, a highly choreographed performance begins in the back of the garages, completely out of sight of the grandstands. The moment a driver crosses the finish line, the car is released into the strict regulatory confines of the secure area, where cars are quarantined to ensure no illegal modifications are made post-race. Once the vehicle is cleared, the strip-down commences. Mechanics swarm the vehicles like ants on a dropped piece of candy. Engines and gearboxes are extracted, serviced, and placed into quarantine. Simultaneously, the non-essential infrastructure of the garage is dismantled. Toolboxes, spare parts, and massive information technology server racks are collapsed, scanned with radio frequency identification tags, and wheeled into the paddock. The packing sequence is an exercise in strict chronological discipline. Transporters are loaded in a highly specific inverted order. The garage infrastructure enters first, followed by the heavy tools. The cars themselves are the absolute last items to be loaded into the trucks. This ensures that upon arrival at the next destination, the cars are the very first items unloaded, allowing mechanics to begin the immediate rebuild of the multi-million-dollar machines while the rest of the glossy garage is magically erected around them. For European races, teams aim to have their entire operation loaded into articulated lorries and on the highway within an astonishing 5 hours of the race's conclusion. But not all circuits are created equal. The glamorous but claustrophobic street circuit of Monaco presents a nightmare. The multi-level paddock means transporters cannot park anywhere near the garages. They are often stationed kilometers away, sometimes parked precariously on jetties behind moored billionaire cruise ships, necessitating extra manpower and days of advanced planning just to move equipment. Then there are the traveling palaces, A top-tier team's hospitality unit can span over 1,200 square meters. Tearing down such a behemoth requires a dedicated construction crew of around 25 personnel working continuously for approximately 32 hours. One team's hospitality unit requires up to 20 dedicated trucks to move its modular components. These crews often work straight through Sunday night, traveling overnight on sleeper coaches just to wake up in a new country and start building again. When the circus departs the highway networks of Europe for flyaway races in locations like Melbourne or Miami, the luxury of road transport is abandoned. The operation shifts to the skies. But Formula One cars do not travel fully assembled, as the volumetric space required would be financially ruinous. Instead, the vehicles undergo a radical transformation. Wings, nose cones, floorboards, and delicate suspension arms are detached. The naked carbon fiber tubs are bolted into incredibly secure, bespoke transport frames. These bespoke shipping containers are engineered to mirror the exact curvature of the aircraft fuselage, ensuring maximum volumetric efficiency. These uniquely shaped boxes are designed to fit perfectly against the curved interior walls of a Boeing 747-400 freighter, a Boeing 767-300, or a Boeing 777 freighter. Every individual component is placed in custom foam-lined, shock-absorbing drawers to prevent even a millimeter of movement. Air freight is notoriously exorbitant, representing one of the highest single logistical costs for any team, estimated at approximately $400 per kilogram. That is roughly $14 million per team, per year. Consequently, equipment is ruthlessly categorized into strict tiers. Critical freight, like chassis and hybrid power units, flies on chartered planes. Priority freight, like garage server racks, flies express air. Now, as we marvel at the immense cost of the air freight operation, a glaring logistical paradox inevitably emerges. If a team is racing in Melbourne on a Sunday, and then scheduled to race in Miami just a few weeks later, how on earth do they transport hundreds of tons of heavy hospitality structures and massive kitchen ovens across the Pacific Ocean via sluggish cargo ships in such an impossibly tight timeframe? The answer is the most brilliant, mind-bending, and highly guarded mechanism in the sport's entire logistical playbook. They do not do it at all. This is the great illusion of the global racing circuit. When a driver sits in their team's opulent hospitality suite sipping an espresso in Miami, it is not the same physical building they sat in during the Australian Grand Prix. It is an identical, perfect doppelganger. To bypass the exorbitant costs of flying heavy equipment, teams utilize an ingenious strategy known as the Sea Freight Leapfrog system. In January, months before the season begins, each team packs 5 completely identical sets of sea freight. These kits contain all the heavy, non-car-related infrastructure required to operate a race weekend. These 5 identical kits are placed on container ships and dispatched to strategically chosen ports around the globe months in advance. While kit number 1 is being used in the Middle East, kit number 2 is already waiting in Australia. Kit number 3 is sailing toward Japan, kit number 4 is en route to Miami, and kit number 5 is positioned in China. Once a race concludes, that specific kit does not travel to the next consecutive race. It is packed back onto a ship and sent halfway across the world to leapfrog the schedule. The luxurious, familiar paddock the viewers see on television is essentially a clone, constantly rotating in a massive, planetary game of musical chairs. But moving massive, multi-ton objects is only half the battle. Navigating the geopolitical reality of global borders is often the more treacherous terrain. A traveling race team consists of well over 100 personnel per race. Over a 24-race season, this equates to managing thousands of individual visas and work permits. Moving the equipment is even worse. To avoid paying exorbitant import duties and tariffs in every single country they visit, teams operate under an international customs agreement called the ATA Carnet, which acts as a passport for goods. It allows for the tax-free temporary import of professional equipment, provided every single item that enters the country leaves the country exactly as it arrived. A single team's packing list can encompass hundreds of thousands of individual items. Every single item requires an accurate description, a financial valuation, and a highly specific commodity code. This strict adherence creates bizarre and highly stressful operational quirks. For instance, if a carbon fiber front wing is utterly destroyed in a high-speed crash on Sunday afternoon, the shattered shards of carbon cannot simply be thrown in the local circuit's trash cans. Those broken pieces must be painstakingly collected, bagged, matched to their original car at entry, and exported back out of the country to definitively prove to customs officials that the highly valuable carbon fiber was not secretly sold on the local black market. Imagine binning your car into a wall at 150 miles per hour, and your logistics manager hands you a broom because you need to declare your garbage to Border Patrol. While billions of dollars are spent optimizing the aerodynamics of the machinery, the most fragile components in the entire traveling circus are the human beings. The schedule demands a toll on the human body that is difficult to quantify. In late 2023, the calendar mandated a devastating transcontinental leap from Las Vegas directly to Abu Dhabi. This involved packing the entire operation into Boeing 777s, flying 20 hours across the globe, and slamming into an 11-hour time difference, all with less than 4 days to rebuild the cars. To prevent catastrophic human error, top teams treat travel management as an integrated branch of performance engineering. Performance coaches map out highly individualized schedules based on specific chronotypes. If a driver is preparing for a brutal 9-hour time shift, their coach will systematically shift their sleep-wake cycle. Strict protocols dictate exact times for sunlight exposure, the mandatory use of specialized, tinted sunglasses, and tightly controlled melatonin administration to force the body clock into submission. Sustaining this high-performance human engine requires a culinary operation that rivals the complexity of the car builds themselves. The paddock caters to approximately 5,000 crew members and guests every single day. Official hospitality providers must construct massive, custom kitchens completely from scratch. A single instance of food poisoning could incapacitate a team's pit crew, rendering a $100 million investment entirely useless. Consequently, menus are meticulously engineered around draconian food safety protocols. Teams rely heavily on massive quantities of pasta to ensure dietary stability. Ingredients defined as high risk, such as raw egg-based mayonnaise, unpasteurized dairy, and raw shellfish, are handled under extreme temperature controls, ensuring they never enter the danger zone between 5 degrees Celsius and 60 degrees Celsius. The catering crews themselves log 80 to 90-hour weeks in extreme heat, sometimes hitting 110 hours over a 7-day period. The physical logistics of moving metal and humans are matched only by the staggering volume of digital data beamed across the globe. A modern racing chassis boasts over 300 highly sensitive sensors, generating a staggering 100,000 telemetry data points every single second. Over the course of a single race weekend, an unfathomable 600 terabytes of data are transferred from the track to the sport's central nervous system located in the London suburb of Biggin Hill. When a driver shifts a gear in Melbourne, Australia, the telemetry data travels across submarine fiber optic cables and arrives at the servers in Biggin Hill in just 160 milliseconds. It is processed, packaged with graphics, and beamed into the living rooms of over 820 million viewers globally in roughly 6 seconds. This massive flow of data also goes directly back to the team's remote mission control centers located at their permanent factories. These NASA-style operations rooms are filled with engineers running thousands of predictive race simulations per minute, feeding actionable strategic advice directly to the track. Beyond the massive cargo planes and the digital fiber optics, the sport relies on hyper-specialized micro-logistics. The sport's sole tire supplier transports up to 1,600 tires per event. The sport's governing body takes absolute control of the allocation process, using a cryptographic barcode system, randomly assigning tires to teams to prevent favoritism. Furthermore, teams do not fill their racing tires with standard compressed air. They inflate them purely with dry nitrogen gas. Nitrogen contains no moisture, ensuring the tire pressure remains absolute and consistent when temperatures exceed 100 degrees Celsius. The logistics of fuel testing resemble high-stakes forensic science. Customized fuel blends are shipped directly from the refinery to the local circuit. The governing body employs dedicated fuel doctors who extract a mandatory 1-liter sample from the car at random intervals. Using a complex gas chromatograph, they generate a highly specific chemical fingerprint. The tolerance for deviation is absolute zero. If a mechanic with grease on their hands accidentally touches the inside of a fuel nozzle, the chromatograph will detect the foreign hydrocarbons and the car is instantly disqualified. And when things break at the last minute, logistics managers deploy emergency couriers. These are individuals whose sole job is to wait for the call, grab a freshly molded carbon fiber part straight out of the factory, board the next available commercial passenger flight, and hand-deliver the multi-million-dollar component to the paddock. It is a bizarre reality that the final piece needed to win a race is often sitting in the overhead compartment of a commercial flight next to a tourist's carry-on luggage. But what happens when the system breaks? The logistics machine operates on the extreme, bleeding edge of possibility. In late 2021, during a triple header, an unexpected fog in Mexico City grounded the chartered cargo planes for a mere 6 hours. It shattered the timeline. The vital cargo arrived in Brazil a full day late. Mechanics worked completely through the night, frantically assembling 5,000-piece cars in less than 14 hours just to make it to practice. A more severe crisis occurred ahead of the 2022 Australian Grand Prix. A cargo ship carrying the vital sea freight kits for 3 teams was delayed in the ocean by over a week. The central logistics partner executed a daring rescue mission, intercepting the delayed cargo ship in Singapore, extracting the containers, and chartering 3 hastily rerouted Boeing aircraft to fly the heavy ocean freight the rest of the way, arriving mere hours before the paddock opened. The ultimate paradox of modern racing is reconciling the burning of fossil fuels with global climate change. In response, organizers have set a target to achieve a net zero carbon footprint by the year 2030. Surprisingly, the fuel burned by the actual race cars accounts for less than 1% of the sport's total carbon emissions. The true battleground is logistics, which comprises roughly 49% of the footprint. To combat this, the sport heavily invested in sustainable aviation fuel, delivering an estimated 80% reduction in associated carbon emissions per flight. On the ground, the European truck fleet transitioned to biofuel, slashing road emissions by up to 89%. Broadcast operations leaned into remote data processing, and the Event Technical Center uses a unique composite material that reduces weight loads by 60%. The most impactful change, however, is regionalization. The calendar was forcibly reshaped to group races by geographic proximity, drastically reducing the overall air mileage required by the cargo fleet. When the 5 red lights extinguish and 20 cars violently accelerate toward the first corner, the true miracle is not simply that the cars can corner at 5 G-forces, it is that the cars, the garages, and the people are there at all. The logistics of a traveling race team represent the absolute pinnacle of human organizational capability. And lying beneath it all is the brilliant illusion of the sea freight leapfrog system, the revelation that the glittering paddocks the world admires week after week are actually 5 separate physical phantoms, silently traversing the oceans in the dark. So the next time the checkered flag falls and the fireworks erupt, spare a thought for the true victors of the weekend. Before the podium has even been swept of confetti, a mechanic has already unbolted a front wing, a forklift has fired its engine, and a 747 is sitting heavily on the tarmac, waiting to chase the horizon. We have to ask you, if you were in charge of moving a multi-million-dollar racing team across the world, which piece of ridiculous logistics would you completely mess up first? Would you lose the bespoke steering wheel in the overhead bin, or would you accidentally fill out the ATA carnet wrong and get arrested for throwing away a piece of broken carbon fiber? Drop your answers down below. Thanks for listening and watching. Please like and subscribe, and make sure to check out our other videos about the global supply chain.